Hello, my name is Corey Applegate, mentor of the Granite City GearHeads, Team 3244 out of St. Cloud, Minnesota. Welcome to week 4 of our 2020 robot chassis build in Fusion 360. The past week we've sketched the perimeter of our chassis. We extruded the profiles to create the tubes, used the shell command to hollow them out, added holes that come pre-drilled into the tubing along with other fastening holes that we put in for our own assembly, and added a few gussets to model how the chassis is assembled. This week we are going to prepare to add other purchased components as assemblies. We have created a library of assemblies that we can use year after year to speed up the process, but today I'm going to show you how to build this wheel assembly. I'm going to start a new design. Before we can import purchased components that we've downloaded from various websites, we have to save our design. I'm going to name this file Example Axle Assembly. Now that we have our design saved, we're going to sketch some reference geometry we can use to build our bearing blocks around. I'm going to select Create New Sketch. To keep the same orientation in this assembly as it would have been on a robot, I'm going to select the front plane. I'm going to draw the outer profile of the tubing using the center rectangle, starting at the origin, 2 inches tall, 1 inch wide. You can see the sketch is fully constrained, depicted by the dark black lines. Finished sketch. I can now import one of the first components using our bearings and blocks folder, dragging in a Versa block. Using the grips, I can start to orient the block as it would be assembled. Since this is one of the outer axle wheels, I'm going to have the V down to raise the axle up the 1/16 of an inch. Just drag it slightly off and place the component. I'm going to join this block, making sure I'm selecting the rigid joint. The first position is going to be snapping to the midpoint of this corner line. To get the right coin on here, I can snap the perspective of the drawing straight on, grab this lower corner, you can see the part snaps into place. Okay. The next part I want to drag into our design will be a bearing. I'm going to select the 1/2 inch hex bearing, drag that into our project. So I can get a good view on all the points I need to snap on. I'm going to leave it as it's oriented, as it's brought in. I'm going to apply a joint. I'm going to select the revolute joint for the bearing. The first snap will be the center of this outer edge circle. The second snap will be the inside corner. You can see the bearing is spinning properly, but is inverted. I can select the flip option to flip the bearing and properly orient. This bearing is now joined to the block and spins appropriately. I could drag in another block and a bearing and repeat the process, or I could use the mirror command, selecting components to mirror. Objects will be the Versa block and bearing. the mirror plane will be the YZ plane. Then OK. What you'll notice when you mirror objects, the joints do not translate to the new parts, so they are free to move. Undo, undo. We can use the assemble joint as built. The first joint I'm going to apply will be a rigid joint to the Versa block. And to the sketch plane. Okay. Using the same as built joint, I'm going to select the revolute, select the bearing and the bearing block, the position to spin around. Going to try to find a coin here in the center of this plane of the circle. You can see the bearing is not revoluting. Okay. We are done with the sketch for now, so I'm going to hide that. We now have our two bearings and bearing blocks. The next thing we're going to add is the axle. In our assets library, we have shafts and sprockets and the Versa hex shaft. Dragging that into the project. Using these controls, I'm going to spin the axle close to where it will end up. Then select OK. We're going to join the axle to this bearing using a rigid command, using a rigid joint, motion, rigid. The first position is going to be the center of this circle created by this corner, and the center of the circle created by the edge of this of the bearing. You can see the rigid joint is applied, but the axle is not quite lined up properly. We can use these grips to try to rotate the axle to fit visually, and also we can make note of the 120 degrees that are applied here. Hex bearings use a 60-degree angle from each surface. 120 makes sense. Okay. Now, as the bearing spins, the axle spins, or the axle spins, the bearing spins. The next part we're going to add will be the sprocket. I'm going to drag the sprocket out to view. Okay. The joint we're going to apply for the sprocket will be a slider joint. The sprocket, as it's installed on this axle, can shift left to right without any spacers. Assemble, joint. The motion will be a slider. The first position selected, we're going to find the inside corner and the coin at the midpoint of that segment. Select. We are then going to find a similar corner of the hex shaft, midpoint coin. Select. We can observe that the sprocket is traveling in the right direction, just not fastened to the axle properly. Again, we can use these grips to spin the part closer into space, and we observe that same negative 120 degree angle to synchronize the flats of the hex, shaft, and sprocket. We could grab the sprocket and drag it into place, but we are going to do something a little more exacting. We're going to apply to the joints some limits, but first we need to take a measurement. I'm going to use the inspect tool to measure from the flat surface of the farthest bearing to the flat surface of this sprocket, making note of the 1.889 inches. Close that. I'm going to select the slider joint that controls the sprocket, edit joint limits. In the maximum, I'm going to type in the 1.889. And we can see the sprocket snaps to flush with the bearing. We do know that there's a 100 thou tube in here, so I'm going to subtract 0.1 to allow for that spacing of the tubing. Okay. Now when we slide this over, we're only allowed to go as far as that limit and no further. We now need to know how far the sprocket can go in the other direction. Snapping this all the way to the side, I'm going to use the measure tool. Measure from this bearing surface to the sprocket surface and make note of the 0.41 inches. Returning back to the slider joint, edit joint limits. I'm going to enter in a minimum distance, and that's going to be the 1.889 minus the 0.41 that we were left with before. Looks like we lost our minus 0.1 for the other way. Okay. The sprocket obeys the max and the min. Most models we make, we do not include the hardware, but for these Versa blocks, we're going to install the 1032 button head bolts that complete the clamping action of these blocks. I'm going to show you how to insert items from McMaster car. But first, we need to know how long the 1032 bolt needs to be. I'm going to use the inspect tool to take a measurement from this edge to the far edge, making note of the 1.5 inch distance. We need a 1032 bolt that extends that 1.5 inch. So going up to the insert tool, we can insert a McMaster car component. We can search for button head cap screws, stainless steel alloy black. We typically use the black oxide. Scrolling down to the 1032 section, we can look for the 1.5 inch long partly threaded. Select the item for more details. Look at the product details in CAD. Scrolling down to the bottom, we'll see that there's a download button. After selecting the model format that we want, we can hit save. And the bolt is brought into our project. Using the same dragging of the tools, dragging of the grips, and rotation, I'm going to get it generally positioned. Selecting OK. I can now add a few joints. Going to select the rigid joint. The first position is going to be the center of the circle created at this transition. The second will be the center of this circle. Select OK. I'm going to make a copy using Control-C and Control-V to paste a copy of that bolt. Drag it where I can see it. Apply a joint, the rigid joint. The first snap will be the center of the circle. Snap to the center of the bolt hole. Okay. Shut off the joints to clean things up, and we now have a model of our axle with a floating sprocket that will stay inside the tube and rotate with everything else. We can now save and use this model in future chassis designs. In the next video, we'll import this assembly into our chassis model, and we'll explore a few problems we'll have to go back and fix when we grounded our chassis, and see why grounding may not be the right answer when building sub-assemblies that will be assembled later on as larger assemblies.